Hello and welcome back. In this video we'll continue with section 2.6 and the first thing that we'll do is we'll look at the domain of some of the functions that we defined in the previous video. So these functions f plus g, f minus g, f times g is when we take two functions and combine them either by adding them, subtracting them, or multiplying them. And the domain of the function is exactly what you would expect. It's just going to be those numbers that you can plug into both f and into g. So it's the domain of f where the domain of f and g both overlap. So for instance, in the example that we were doing in this last video, where our two functions were x minus 5 and x squared minus 1, you can see that the domain of x minus 5 is going to be all real numbers. We're never dividing by 0. We're never taking a square root of a negative number. We can plug any number we want in there. The same thing for g. We can plug any number we want into there. So the domains of these two functions are all real numbers. So the domain of f plus g, the domain of f minus g, and the domain of f times g are also going to be all real numbers. The only time that we have to be a little bit careful is when we're dividing by a function and we don't want to divide by 0. So we want to be a little bit careful when we're talking about the domain of a function divided by another function. First of all, in order to plug a number into this, I have to be able to plug it into f and into g, but also I need that the bottom of the function is not 0. So let's do a quick example here. Let's find the sum of these two functions, and let's find the domain. So f is the square root of x minus 3, g is the square root of x plus 1. So let's write down what f plus g is. So this is going to be another function, and the function again is just going to be f of x plus g of x. And we can write down exactly what f of x is and exactly what g of x is. Oops. And there's no more simplification to do. This is it. So now we need to find the domain. So we need to figure out what numbers can we plug into f, and while at the same time we can plug into g. So for f, when I'm trying to find the domain of f, in my scratch work, I'll look at this and I go, I can't take the square root of a negative number. So what we don't want in my scratch work, what we don't want is we don't want x minus 3 to be less than 0. This is what we don't want. So if I add 3 to both sides, I'll get that x is less than 0. This is what we don't want. So what we do want, what the domain of f, excuse me, I didn't write a 3 here. So the domain of f is going to be everything that's not less than 3, meaning it's all of the x's that are greater than or equal to 3. If we look at the domain of g, on the other hand, we can't be taking the square root of a negative number. So I want x plus 1 to certainly be a positive number, so I can't let it be negative. This is again what we don't want. So if I subtract 1 from both sides, I'll get that x is less than negative 1. Well, this is what we don't want. So if x can't be less than negative 1, x has to be greater than or equal to negative 1. So if I draw my number line here, we've got 0, negative 1, 1, 2, 3. The domain of f, I can only plug things into f that are greater than or equal to 3. But I can only plug things into g that are greater than or equal to 1. So when we look at this, we look to see what numbers can I plug into both f and into g, and we can see that, only numbers that are greater than 3 will satisfy both of the domains. So the domain of f plus g is going to be all those numbers that are greater than or equal to 3, because they have to be both greater than or equal to 3 and greater than or equal to negative 1. So where they overlap is going to be from negative, is going to be from 3 on. So writing this as an interval, this will be from 3, oops, I've got to be careful. This is going to be 3 to infinity, and I can include 3, but I can't include infinity. So this is just calculating the domain. This is where the domain of f and g overlap, just using a picture. The last way to combine functions, I think, is easiest when I draw a picture to sort of describe what's going on. So I think of functions as little machines. We've got an input and we've got an output, and as our x goes into our function f, out the other side will come 2x. So for instance, if I've got my function and I plug in a 3, out the other side will come a 6. So maybe we also have another function which I'll call g of x. And this function, maybe this is the +1 function, and we'll just add 1 to whatever number we plug in. So again, with g, it's a little function, and we've got our little conveyor belts, and when we have an x that travels into the machine, out the other side comes an x plus 1. So over here, for instance, if I plug a 3 into g rather than into f, we will end up getting 4. G just adds 1 to the input. Now, the new way of combining functions is going to be to put these functions in series, and whatever we plug into one, it's just going to go right into the first one and then out the second one. So let me put these two functions together. We'll link them with a little conveyor belt. And for reasons that I'll explain in a second, I want to do g first and then f. So here, when I plug x into here, I know that we get an x plus 1 coming out. But now I want to plug an x plus 1, and it's going to go right into f. F just takes everything times 2. So out the other side, we're going to get 2 times x plus 1. So here, we've strung our two functions together so that whatever we could put in, it'll come out and go right into the next function. So for instance, if we plugged in a 3 into g and had this run over here into f, g will add 1 to 3, so we get 4, and then we plug 4 into f, and then ultimately we will get 8. So this is called composing functions. So for the composition of functions is denoted by f composed with g. So this composed with symbol is just a little circle. And what it means when we write f composed with g is the following. We first take x and we plug it into g. So we do the second function first, the one that's closest to x, and then we plug everything into f. So this may seem a little bit backwards. We're working from right to left, but the way to think about it is we're working closest to x and away. So we first plug x into g, and then we plug whatever we get there into f. So up here, this function here, I could write as one big function that is f composed with g. And when we plug in a 3, we get an 8. Or more generally, with our big f composed with g, when we plug in an x, we're going to get a 2 times x plus 1. So let's do an example of this. We have our two functions, f and g. F is going to be 2x plus 6, and g of x is going to be 2x squared minus x minus 1. So we have to remember, this is very, very important, we have to remember what order we do things in. We always work closest to x and then away. So what we're going to do is we're going to take x and we're going to plug it into the function that's closest to x first, and then whatever we get, we're going to plug into f. So ignoring the f for the moment, I'm just going to write down what is g of x. G of x is going to be 2x squared minus x minus 1. So all I've done is I've substituted what g of x is into this function. Next, I'm plugging this whole thing into f. And what do we do when we plug something into f? We take it times 5. And then we add 6 to it. So right now, I could stop. This is the function that I want. I'm going to simplify it so that it's a little bit easier to read. So I just need to distribute the 5. So 5 times 2x squared is going to be 10x squared. 5 times negative x is negative 5x. 5 times negative 1 is negative 5 plus 6. And we have two like terms, so we'll just simplify that. Minus 5x minus 5 and plus 6 is going to be plus 1. So here is our simplified answer for what is f composed with g. We plug x into g and then into f. We can do the same thing, but in reverse as well. We can plug f into g. So here, let's, again, we work closest to x. So we're going to take x, we first plug it into f, and then we plug it into g. So f was 5x plus 6. So I replaced the f of x with 5x plus 6. And now I need to plug all of this into g. And g is going to be 2x squared minus x minus 1. This is quite long. So this will be 2 times the input squared minus the input minus 1. And then we can simplify. So if I FOIL that out, I'll get 25x squared plus 60x plus 36. I can distribute the negative sign, minus 5x plus 6 minus 1. I can distribute my 2 now, so this will be 50x squared plus 120x plus 72 minus 5x. I'll combine these terms at the end. Plus 6 minus 1 is minus 5. And combining my like terms, I'll get 50x squared plus 120x plus 67. Oh, excuse me. I have missed some like terms. I will start over here. 50x squared, 120x minus 5x. Well, that's 115x. And 72 minus 5 is 67. So one thing that you'll notice right away is that this is different from this. The order of functions matters. You've got to start with the function that's closest to x and then work out. And then for f of g of negative 1, so f composed with g of negative 1, there are two ways to do this. Again, we can do this in the way that we had been doing, where we apply, where we start with negative 1, we apply g to it, and then we apply f to it. So g of negative 1, g is 2 times x squared minus x minus 1. So if I simplify everything in here before I plug this into f, 2 times negative 1 squared is just 1, so that's 2 plus 1 minus 1. So this is going to be 2 f of 2, and f is 5 times the input minus 6, which is